Hi, this is Josh White with JW Math Tutoring, and this video is going to go through solutions and explanations to the May 2022 SAT QAS, specifically Section 4, the calculator section. I'm going to go through all 38 problems and show you how to solve all those problems in depth, including some problems that you can solve using multiple methods. That's why you'll see this video will probably be a little bit longer and more detailed than some other explanation videos out there for SAT, QAS release tests. But I feel that it's best to show students that there are multiple ways to solve a lot of these problems and to go through each one in as much detail, as possible. Now, if you like this video, please, be sure to click the like button. Also, sign up for notifications so you find out whenever I post new videos. And of course, subscribe to my channel as well, just so you can be notified whenever there's new SAT math-related content or any math-related content just in general. There hasn't been a lot of SAT-specific math-related content so far, but there definitely will be in the next couple of weeks. So with that said, let's go ahead get started on the May 2022 SAT QAS Section 4 calculator problems.
But life is a dream that calculus could never predict.
Now we're going to start going through the calculator section of the May 2022 QAS US version of the SAT. So first problem we have here is just a basic evaluating functions problem. You could type this into your calculator if you wanted to, but you don't need to. It's fairly quick to do it by hand. We're just going to find f of 3, which means we're just plugging 3 in for x. Then order of operations, 9 times 3 is 27. 27 minus 16 is 11. So correct answer is just going to be letter C. Below that, we have problem number 2. And this one might look a little confusing because you're given an equation and then you're given another equation. And you're asked, which ones have the same solution. But if you take this original equation and just attempt to solve it by doing the first step you would do, which is to add 7 to both sides, notice you get 6x equals 19. Okay, which of these answer choices does that match? Well, it's just letter D, and that's it. So that's really all you have to do in this problem, is just add 7 to both sides, and then essentially you get an answer that matches the work you did with the original equation, and there's nothing else that you need to do. Moving on to the problem directly below it, number 3. Here we have a graph of a function, and it says, what is the y-intercept of this graph? Well, it might be a little difficult to see here because it's kind of small, but the y-intercept, of course, is where the graph crosses the y-axis. It's this point right here. It is just up 2 units from the origin, so it is going to be 0, 2, and that's it. You're just identifying a point off a graph. Problem directly below it, number 4. We have another graph of a line. But now it asks for the equation of this line. So there are multiple ways you could do this. I would say the most common way would be to look at the line. Notice that its y-intercept is right here at positive 5. So its b value is just going to be 5, or the point is 0, 5. Now to get the slope of the line, we basically have to count between 2 points. So when I look at this line, I'm looking for another point where it is basically right at the intersection of 2 of the number, kind of grid marks, like not halfway between one of them. So it looks like the next intersection is right here at the point 1, 2. So if I start up here at 0, 5, I go to the right one, and then I go down 1, 2, 3. Therefore, my slope is going to be negative 3 over positive 1. So now I could just put it into slope-intercept form. It would be mx plus b, or negative 3x plus 5. And the correct answer for this one is just going to be letter A. Now, an alternate method, just if for whatever reason you forgot how to find the y-intercept, or you forgot how to find the slope, you could technically go to the calculator, go to the stat menu, and you could put in any 2 points from this line here. So let's say we have our first point 0, comma 5. Basically what I'm going to do is I'm just going to do a best fit line or linear regression on 2 of the points, and it's going to give me the slope and y-intercept, and then that'll also confirm the answer. Then for our second point, I would just use the 1, comma 2, right here. So I'll put in 1 for basically the x column, and then for the y column, I'll put in 2. All right, back to the stat menu, go down to calc, go down to option 4, hit enter. It's a lin reg ax plus b. I want my x's in L1, I want my y's in L2, and then I go to calculate. Okay, so A, my slope is -3, and B, my y-intercept is 5. So that's just an alternate way you could get it if for some reason you forgot how to get the slope of the line, or which point specifically is the y-intercept. All right, moving along. Next question directly below it is number 5. And this one reads about the 50 states in the US, and basically just asking to find a percentage. So, I mean, all you're doing here is just basically finding, 12 out of 50 is what percent. So you just divide that on the calculator. Okay, it comes out to 0.24, and that's just going to be equal to 24%, or letter B. Also, just so you know, a little trick here, slightly quicker way to do this might be to notice that when you have 50 as your denominator, if you multiply that by 2, you get 100. So an alternate way to get 24% is just take the 12 on top, or whatever the number on top is, multiply it by 2, that's your percentage if it's out of 50. Now, continuing, we move up to the right, the next column. Just slide across here for questions 6 and 7. So you're given this little description information here, and you're given an equation where T represents basically total food that these chickens eat, pounds, and X is how many male chickens there are, Y is how many female chickens there are. Okay, so in problem number 6, you're given that there is 90 pounds of total food, total feed intake. So T is just 90, and you're told there are 100 male chickens. So that means that X is just equal to 100. And basically you're asked for the number of female chickens, so you are asked for the value of Y. So this is just turns into a basic linear equation you could solve. If you multiply 100 by 0.32, it's just 32. So you get 90 equals 32 plus 0.29y, and then you could just subtract 32, and you get 58 equal to 0.29y, and then you just divide both sides by 0.29. Y comes out to 200. So the correct answer is going to be letter B. Now, this one you also could solve by using back solving. And so what I mean by that is you could take the answers, you could plug them into the equation, and you could see which one works. Just if you're having trouble solving equations, especially since there's a decimal in it. So what I mean by that is the equation is 0.32 times, the 100 for the number of male chickens, and then plus 0.29 times, and I'm going to start with the first answer, choice A, and I'm going to hit enter and see, does this equal 90? Okay, notice that no, it does not. So now I'm going to move on to the second answer choice. So I keep everything the same. I'm just going to replace the 191 with 200, hit enter. Okay, there I get 90. So that might even be easier or quicker than the method that I used, which was actually solving out the linear equation. Okay, so again, this number 6 you can also solve using the property of back solving or plugging in the answers. Now, for problem number 7, the one directly below it, we're using the same basic information. Essentially, what we're going to do for this problem, though, is we're going to estimate the total weekly feed intake in pounds for both X and Y. Okay? So, first of all, the 28 and 35 days old thing, that's irrelevant. That's already given information in the problem up here that this formula applies to. So, you don't even need to do anything with that. That's just telling you that it meets whatever criteria that you're given. So, again, if you look at the equation here, this is the daily intake. So, if you wanted to find the weekly intake, well, that would be the total amount of food each day over 7 days. So all we have to do is essentially take this entire thing and just multiply every single term by 7. So multiplying 7 by the daily intake, T, would give us the W, which is the weekly intake. And then on the right side, you're going to multiply both of these terms by 7, i.e., the amount of food eaten every day by all the males. So that's this whole expression by 7, and the amount of food eaten every day by the females. This whole expression also by 7. The correct answer is going to be letter D. And notice in D, they just have the 7 out front, and then the 2 terms in one giant parentheses rather than distributing it to both terms. Okay, so you might think of like having the 7 in front of each of them, but basically if you just factored the 7 out front and then had the 2 terms added together, that's just an alternate way to write it. Again, we're multiplying everything by 7 because 7 days in a week, so we take the daily amount, we multiply that by 7, that gives us the total amount for the week. Okay, the next problem we have coming up here is problem number 8. And here we have a function, but now instead of evaluating it, we're actually given the output of the function, and we're essentially asked to find the input. So in other words, the output is 13, but we're asked, and we want to find, what x value gives us that output. So this is just a basic quadratic equation to solve, and specifically, it's a quadratic equation that we can solve using the square root principle because there are no x terms. There's only x squared terms and number terms. So if you add 3 to both sides, notice you get 16 equals 4x squared. Then just divide by 4. You get 4 equals x squared. Then you would square root both sides. And you get x equals, now the square root of 4 is 2, and technically when you introduce the square root, you have to always put a plus or minus, but the problem asks only for the positive value of x. So therefore, we do not need the negative 2. We only want positive 2, so the correct answer is number 2. Again, an alternate method that you could have used to solve this is back solving. So what I mean by that is you could just go and start with plugging in the answer choices on the calculator and seeing which one gives you 13. So for some reason, if you didn't know how to set up the equation, or if you set up the equation but then were having difficulty solving it or forgot how to solve it, all this question is basically asking is, what number when you plug it in for x do you get 13 as your output? Obviously, the first answer choice you got is correct, but if for some reason it wasn't answer choice A, and let's say we needed to try answer choice B, so I would just here replace the 2 with a 4. Okay, is the answer 13? No, it's not. Okay, that proves that this one is incorrect. And you could do the same for C and D. You just have to, inside the parentheses, put square root 10 divided by 4, and just as long as it's in one parenthesis, it would do the order of operations correctly. But again, back solving is an alternate strategy you could use to solve this problem, and that works on most problems where you have equations that you're solving for a specific numerical value. Okay, the next problem up is number 9. This one deals with some properties of geometry. So the first thing I would do here is I would just draw a picture of these two triangles. So like whatever, here's the first triangle, and then here's the second triangle. Doesn't really matter if they are to scale or not. It just helps to visualize it when we go ahead and draw the pictures out. So we know A is 23 degrees. We know B is 97 degrees. Again, these are not to scale, but that's irrelevant. All we're trying to do is just match things up. D is 23 and E is 97 degrees. Okay. So which of the following pieces of information determine whether these two triangles are similar? So it turns out the correct answer here is D. You do not need any more additional information because these two triangles are similar by the AA similarity postulate. Basically, if you have two pairs of congruent angles, then a pair of triangles will be similar. So the minimum that you need is two pairs of congruent angles, because technically the third pair of angles would be congruent as well because they each have to add up to 180 degrees. So if you subtracted the two known angles in each triangle, you would get the same value for, say, angle C and angle F. And then all three pairs of angles would be congruent, and that's technically part of the definition of similar polygons, or in this case, similar triangles. There are also other methods to prove that two triangles are similar. You have basically SAS and SSS. But in those cases, the sides are not congruent to each other, but they are proportional. But for this example, so those would be like SAS would be two pairs of proportional sides, and then the included angle between them is congruent or has the same measure. SSS, all three pairs of sides are proportional, but you don't need any information in this case because we have two pairs of congruent angles. Okay, the next problem is problem number 10, just at the bottom of this page. Here we have some points. Basically, it's a scatter plot, on a coordinate plane, and it's graphed out. It says which one is the most appropriate model for this set of data. So essentially the easiest or the quickest way to do this is just to kind of draw a basic line through the data right here. And notice that first of all, it looks like it's crossing the y-axis like up here around +6. So right away we could eliminate C and D. And then notice also that the slope of this line is negative. Therefore, it has to be answer choice A. It cannot be answer choice B, because in answer choice B, there's a positive slope line. So just by looking at those two characteristics of the graph and then using process of elimination, we don't actually have to solve anything out or figure anything out. Now, technically, again, another way you could do this, if you weren't sure, is to go back and do the Lin-Reg function on the calculator. So let's say I went back to the stat menu. Okay, and so I'm just going to pick like whatever, this point here, which is at 1,6. So for my first point, I'm going to put in 1 for the first column, then 6 for the y column. Okay, so like right here, and then I'll use 4,1 as the other value. So actually this should be 1 because I'm in the y column, and then I'll move back to the x column and put in 4. And then we'll go to stat, again, go to calculate, go down to option 4, go down to calculate. Okay, so notice these are not the exact values for the answers, but when you do something like this, you're only looking for the ones that are close enough where that makes sense. So if I erase and look at all the possible answer choices, okay, the B value is like 7.6. Notice it's positive, so it's obviously not going to be these because, again, they don't make sense. They're the wrong sign, and they're very far away from positive 7.6. And now when you look at the a value, which is the slope, it's negative 1.6. Again, this is positive, so this cannot be correct. It just has to be this, again, by process of elimination. So that's an alternate way you could solve this problem or figure it out. Again, if you did not think to just draw a line and estimate it from that given line. All right, the next problem now we have is problem number 11. And when you read this one, it looks fairly complicated. You know, there's a lot of words here and everything, and talking about cross-sectional area and the different units, milliamperes per square millimeter, blah, blah, blah. But all you need to know is that basically current density, current divided by area. That's basically what it tells you in the first sentence. Current density is equal sign current divided by area. Those are all the key words. You don't need any of the other stuff. And then as we're reading through, what is the current density? Okay, so that's what we're trying to figure out. But cross-sectional area is 6 square millimeters, so it's 6. And the current is 15. So you're literally just plugging in 15 for current on top, 6 for the area on the bottom, and then you just simplify this or divide it out, and it comes out to 2.5. And that's it. One thing you do want to check is just that all the units match up. In other words, here it's given, notice it's given milliamperes and square millimeters. And when you look down here, okay, milliamperes, that matches up, and square millimeters, that matches up. Sometimes on harder problems, you will see where the units are different, and you need to do a conversion from like feet to inches, or whatever, square feet to square inches, that kind of stuff. But you don't need to do that in this one. This one is really just divide two numbers, and that's it, based on the formula. Okay, below it we have problem number 12. And they give you the equation of a circle in standard form here. Just to review, if you're not sure, standard form is x minus h squared plus y minus k squared equals r squared, where h comma k is your center of your circle. And your radius is just basically the square root of the number on the right. So the radius of this circle in this problem is just going to be equal to the square root of 64, which is 8. Letter C, that's it. There's no more work to do. By the way, the center of the circle, just for practice, is 9, 3, but you don't need that to solve this problem. Okay, next problem is number 13. So you're given an equation, and notice here's what we have to, they're asking for the value of x plus 1, not of x itself. A lot of students will solve this problem out. They'll get the value for x, and then they will select that as the correct answer. But you have to be careful. They don't want x, they want x plus 1. So if you take this equation, since it's basically a proportion, like we could put this 3 over 1, first thing you do is just cross multiply it. So 6 times 1 is 6, and then 3 times x plus 1. Now, you might be tempted to distribute this out, and you get 6 equals 3x plus 3, and then you think, okay, subtract 3. And this is a perfectly acceptable way to solve it. So you get x equals 1, but again, that is not the answer because they want x plus 1. So x plus 1 equals 1 plus 1, which is 2. So the correct answer is going to be letter C. Now, I just want to show you, technically you could have skipped all of this work if back in this step up here, if you notice, if you do not distribute the 3, but instead if you divide by the 3, and then it becomes 2 equals x plus 1. And now notice it's already solved for what they're asking for. So that's just a quicker kind of shortcut way to get the answer to this problem. But if you don't recognize that, that's fine. You can just solve it out. It's really not that much longer to just solve the linear equation and then just add 1 to it. But you do need to remember just to add 1 to your answer. Next we have problem number 14 below it. This one deals with a quadratic function, and basically what you need to know here is that whenever you have a quadratic function, the maximum or the minimum occurs at the vertex, and all of these equations are in what's known as vertex form. So basically it's y equals a times x minus h squared plus k, and h and comma k is your vertex. So here it tells us that the maximum occurs 1 second after being kicked, so t is 1, and the maximum height that it achieves is 16 feet. So essentially 1 is going to be your h value, and 16 is going to be your k value. And the reason we know that is because, notice it says a quadratic function models the height h of t. So because t is in the parentheses, that means that that's your input, or that's basically your independent variable. In other words, that's what's going inside here. Of the ball t seconds after he kicks it, blah blah blah, and the h, or the height, or the output, that's what's going to correspond to the y value of your vertex, or your k value out here. So for this problem, the answer is going to be letter B, because our vertex, or our maximum point, it basically has an x value of 1 because t is 1 second, and a y value of 16 because it goes 16 feet in the air. And also, if you graph this quadratic function out, it would open downward like this. Next, we have problem number 15. Here we have another problem where we have a bunch of points on a graph, except that here they show the line of best fit, and they want to know how many of the points is the actual y value at least one greater than the y value that's predicted by the line of best fit. So, okay, be careful here. We want actual. By actual, what I mean is like, the actual dot greater than predicted. And by predicted, what we mean is something on the line. So notice that there are 3 total points, and it might be a little small to see on the screen here, but it's basically this one, and this one. There's 3 total points where the actual is greater than the predicted, but specifically they want it where the actual is more than 1 greater than the predicted. So let me just zoom in here to see if I can make it as large as possible. So notice here the actual is like probably 1.5, and the predicted is 1.5 and the actual is 2. So that one will not meet the criteria of the problem because the actual is not 1 more than it. In other words, we want the vertical distance between the point and the line to be more than 1 unit. So for this point right here, that appears to be the case because it looks like the predicted is like 4.6, 4.7, whereas the actual is 6. So that one checks off. And the same thing up here. The predicted is like 6.5 maybe, and the actual is 8. So that is more than 1 unit above it. So that one checks it off. So let me just zoom out now again. So there are 2 points for this problem. Correct answer is letter B, where the actual y value is at least 1 unit greater than the predicted. And again, what we're looking for here is basically the vertical distance between like the dot that we actually see and where the dot is on the line itself to find the answers to this problem. Continuing now with the next problem, number 16 at the top of the page. So in this situation, basically they describe something that's going on. They give you an equation. Really, it's just a basic one variable linear equation, and say which of the following is the interpretation of 48R. So notice that 3,000 is a number of pieces. Same thing, 216 edge pieces. So 216 right here. These are both like numbers of pieces. So that means 48R has to be a number of pieces as well. And specifically, notice that 3,000 is the total, 216 is the edge, and it tells us the rest are inside pieces. So this whole thing right here is just going to specifically represent the total number of inside pieces. So correct answer for this one is just going to be letter D. Below that, problem number 17, we have a system of linear inequalities. And it says, which ordered pair is a solution here. So there are multiple ways you could do this. I mean, technically you could like graph them each out, and then you could see which pair is in the shading of the overlap. And I'm actually going to show you how to do that on the calculator. But the easiest way, the quickest way, method one, I'm just going to show you is back solving. So just take the answer choices, plug them in. The one that's going to be a solution is going to work in both inequalities. So for example, answer choice A, negative 2, 3. We go ahead in the first one and we plug that in, we would get 3 is less than negative 3 times 2 plus 1. Or we would get 3, this should be negative 2. So we get 3 is less than 6 plus 1. That is correct, so that checks. But then let's check in the second one. 3 is less than or equal to negative 1/2 times negative 2 plus 1. So we get 3 is less than or equal to negative 1/2 times negative 2 is just 1. So 3 is less than or equal to 1 plus 1. That is not correct because 3 is not less than or equal to 2. So we could go ahead and cross it out. Next answer choice, we'll go ahead and check it. So in the first one, we get 2 less than negative 3 times 1 plus 1. 2 less than negative 3, if we multiply these out, plus 1, negative 2. Positive 2 less than negative 2, that doesn't check, so we don't need to bother checking the second inequality. Answer choice C. Let's check the first one. So we got 2 for the y less than negative 3 times 0 plus 1. 2 less than 1. Negative 3 times 0 is 0, and 0 plus 1 is 1. 2 is not less than 1. That does not check. So by process of elimination, it has to be D. But just to show you real quick, if you want to go ahead and plug it in, we would get 1 less than negative 3 times negative 1 plus 1. 1 less than 3 plus 1, 1 less than 4. Okay, that checks. Now, let's check in the second one. So we have 1 less than or equal to negative 1/2 times 1 plus 1. Here, if you're not comfortable with doing the fractions, you could just do this on, this should be a negative 1 in there. You could just do this on a graphing calculator or scientific calculator, but it's going to be 1 is less than or equal to 1/2 plus 1. 1 is less than or equal to, it's basically 1 and 1/2 or 3/2. That checks, that is true. That confirms that the answer choice is D. Now, here's an alternate way you could solve this just by graphing each of these on a graphing calculator and then seeing which point lies in the solution set. So go to the y equals menu, and I'm going to type in the first one, negative 3x plus 1. And you might find this quicker than some of the work I just did, although if you were doing the work on a graphing calculator, for the numerical calculations, you could probably get it done a lot faster than me just working through it. Okay, so negative 1/2 times x plus 1. Now I'm just going to set the correct inequality symbols for the shading. So the first one should be less than. So we want this one right here that's pointing down and to the left, basically pointing the southwest direction. And we want the same thing for the next one, for the second inequality, because it is less than or equal to. There's no distinction on the calculator for like less than versus less than or equal to. That just, basically means the line is shaded versus dashed. So we just want the same inequality symbol. So now we'll go ahead, we'll graph it out. So that's the top inequality. That is the second inequality. And so basically the area where they overlap or shaded, where it's like purplish down here, this is the answer to the problem. This is the solution set to the problem. So now if we go back here, and I'll just erase them real quick so we can look at them again. So negative 2, 3, that's probably not going to be in the shading thing because that's going to be um, like somewhere right up around here. But you could confirm, you could move your cursor on the graph, just to confirm that. So like, let's say, whatever, I go to trace. And let me actually, jump down to this one. Okay, so here, when it's at like negative 2.12, notice that its y value is like 2.06. So negative 2.3 would be above like where I am on the second inequality right now. So it is not in the shaded region. And 1.2 would be, again, somewhere like over right around here. That is not in the shaded region. 0.2, again, would be right here, not in the shaded region, but negative 1.1 is going to be in the shaded region. So that's just an alternate way you could solve this problem by using a graphing calculator, and you might find it quicker than the other method. Okay, now taking a look at the next problem, number 18, directly below it. Here we have basically a table. Essentially it's like it's a two-way table, but there's more than two columns in it, with a bunch of data from a poll. And so you can go through and you can basically just figure each of these out by looking at the data that's listed up there, and then just see which one's greatest. Either you would know it by looking at it, or you could just divide them all out on the calculator. So for example, the first one, if we're given the person is from county 1, that means our denominator, or our total number of possible outcomes, is 1601. And then on top, for the favorable outcomes, we want the person being undecided. So it's 95 out of 1601. It's going to be a pretty small number. For answer choice B, same thing, but county 2. So we look at the total up here for county 2. That is our denominator. And we put our undecided for county 2 right here on top for our favorable outcomes. So it's 91 out of 1144. Notice that here the top is a little bit smaller in choice B, but the bottom is much, much smaller. That's actually going to make choice B a larger number than choice A. So choice A is actually out. Again, if you don't believe me or not sure, you just divide these on the calculator and you can compare them. For answer choice C, we have the person is undecided. So that means now the denominator is going to be the total number of undecided people, because we're selecting from only the people that are undecided. So we have 186, and the number of favorable outcomes is going to be 95, because the favorable outcomes of the person being from county 1. And then D is going to basically be identical, except it's now going to be 91 over 186. So the answer to this is going to be letter C. Basically, if you compare C versus D, they have the same denominator, but the numerator, the top in C, is larger. So that's what eliminates D. And if you look at B versus C, you can see the top in C is larger and the bottom is significantly smaller. So correct answer is going to be letter C. If you're not able to determine that just by looking at these fractions, just punch them into the calculator and compare the decimals. And you'll see that C is going to be the greatest value. Next up, below that, we have problem number 19. Here we basically have a bar graph, and it's asking about the difference between the mean number versus the median number of commercials per day. So we have two things to calculate here. First, for the mean or for the average, we're going to take these values from each day and we're going to add them all up and then divide by the total number of days, which is 5. So you're just going to add up 16 plus 5 plus 7 plus, let's see, 8, and it looks like the last one is at 14. Okay, and again, the numbers I'm getting are just the numbers for each of the bars here. 16, 5, 7, 8, 14. So you add all those up, they add up to 50. You divide that by 5, and you get 10. So the average or the mean for the number of commercials per day is 10. Now for the median, basically what we have to do is see what is the middle number. And what we're talking about is, like, for the number of commercials per day, there's basically 5 different values we have. So if we did them from smallest to largest, it would be, for example, 5, 7, 8, 14, 16. Since we have an odd number here, that means we're going to have exactly one middle number. So it's like if you start at the left and work your way in, 8 is going to be what's in the middle. So therefore, the median for this set of data is going to be 8. So how much greater is the mean than the median? So 10 minus 8, it is 2 commercials basically per day greater than it. So correct answer here is just letter A. Now moving on to the next page, problem number 20. So this one talks about basically a sample of a set of data, and it wants to know, like, so they sampled 100 students about this high school, from all high schools in the county, and then they want to know, like, what's the largest, population or group of students that you could, generalize or apply these survey results to. So the answer is going to be letter C. And so basically, the results of the survey can be applied, first of all, they can be applied to everyone. They would not only be applied to the people that approved of the time change or the people that didn't approve of the time change. And assuming the survey was set up, in a mathematically valid manner, it would not just be applied to the people that completed it. The goal of the survey is you take opinions from some small number of people, and then you can apply that to a larger group of people that the small number of people represent. So it's not just A and B, because those are just two kind of like, small subsets. It's going to be letter C then, which is all students in the county, because you cannot apply this to all students in the state because you only surveyed students from one specific county. So in order to apply it to all high school students in the state, the survey would have had to have been done across the entire state. Okay, so because they only selected students from an entire county, that's the largest group or largest population that you could apply the results to. So correct answer is just letter C. All right, and the next problem we have is number 21, which deals with this bar graph that is shown here about businesses in Iceland. So in problem 21, it basically asks for the average or mean number of employees per tourism-related business. So we know how many total people apparently were employed, which is 13.5 thousand. So to find how many, what the average is per business, we would just have to divide that by the number of tourism-related businesses in 2009. So go to 2009. Notice the lighter gray color is for tourism-related. So this one, you could just now divide it by 0.58, and you actually don't need to convert each of these into the thousands, meaning you don't need to make it 13 comma 500 and 580. You could just keep them both in terms of these um, number of thousands, and you could just divide them out and then see what your answer is. So if you divide this on the calculator, you get about 23.27, and then that would just round, to 23 right here. So really what this is asking is there are 13,500 people that worked at tourism related businesses. There were 580 tourism related businesses. So what was the average number of people, that worked at one business? And again, you just divide the two numbers, comes out to about 23. Now, for problem number 22 below it, it says in 2008, we want the total percentage of total businesses that were tourism related. So if we go back to the graph here, notice that, so first of all, we're looking at now 2008, not 2009, so different year, and that like tourism related businesses make up or already included in this total. So in other words, all we need to do is take the number of tourism-related businesses, which is 0.52, the lighter gray line, and then divide that by the total number of businesses, which is 2.6. So it would just be, like I said, 0.52 on top, 2.6 on the bottom. Again, you don't need to convert these to like 520 and 2,600. You can just keep them in this form and just divide the numbers that way because you're basically getting a percentage. So you go ahead, you do this on the calculator. It comes out exactly to 0.2, which is then just equal to 20%. So correct answer is going to be letter B. 20% of the businesses in Iceland in 2008 were tourism related. Now, below that, we have the next problem, number 23. And in this problem, you're told about, whatever the heat capacity of water is this amount, and they want to know, okay, how much energy is required to raise the temperature of whatever, 1 gram of water from 22 to 30 degrees. So the heat capacity is the amount it takes to raise 1 gram by 1 degree. Okay, and then they tell us what the actual heat capacity is. So now, instead of raising it by 1 degree, we want to raise it by 8 degrees. So all we have to do is just take, this 4.2 number, that's the amount of energy to raise it by 1 degree, and just multiply that by 8, which is just 30 minus 22, because we want to raise it by 8 degrees. That comes out to 33.6, and then notice it says approximately, so we just round it, off to 34. So correct answer is just basically 34 joules, letter C. At the top of the next page, we have problem number 24. So for this one, first I'll just talk about like the theoretical solution behind it, but then I'll show the picking numbers solution, which I think may be the easier way to do it. So here they give you this equation and they tell you this is like the value of something, t years after whatever. But then they ask about changing it such that rather than plugging in like number of years, you're going to plug in number of months. So if you want to get the same value here to make everything the same, like for the exponent. So for example, let's say that you were going to look at it after, t equals 3 years, right? You would need this exponent up here to be 3. And we know that 3 years is equal to 36 months. Okay, just multiply 3 by 12, and that's how we get 36. So 36 is what we'd be plugging in for m, and we need it to work out such that the way it would look after you plug it in is, we'd have 1,000, and we'd have, like, say, 1.05 to the third power. In other words, that's what we get when we plug in 3 for t, and this is also what we want to get when we plug in 36 for m down in these possible answer choices. So if you look at it, like d looks pretty similar, except your exponent would be 12 times 36, which is obviously not 3. So get rid of that. and you look at A and B, notice they have numbers here like under the 1000 and under the 1.05, and that should not change. Like that's not going to match. You know, if you make this and if you make this a 36, it's not going to be to the third. But then if you look at C, notice if you plug in, say, 36 up here, 36 divided by 12 would just simplify to 3, and now it basically matches the original equation, you know, when we plugged in just the straight value of t. So the answer choice is going to be letter C. That's going to be the correct answer. But now I will show you a second method, which is using picking numbers to just plug these, basically plug these values in on your calculator and figure out what the correct answer has to be. So first of all, we said that t equals 3. So that means if we just evaluate it, type in 1000 times 1.05 to the third power, okay, we get 1157.625. 1157.625. So now when we check A through D, that is the value we're looking to get. Hopefully only one of these answers we know will give us that number when we plug in 36 for M, and that's going to be the correct answer. This is basically the whole idea of picking numbers. You know, we picked a value for T, and then as a result, we have a value for M based on that T value, and then we're going to plug M into our answer choices and see which one matches what we would expect based on the original formula. So for answer choice A, I'm going to have 1,000 divided by 12, and then times 1.05 to the 36th power. All right, clearly not 1157.625. So that's wrong. So now if we checked answer choice B, we would have 1,000, and then we have 1.05 divided by 12, and again it's raised to the 36th power. All right, some fantastically small number, not the right answer. Answer choice C, basically you'll see, will be correct. So we have 1,000, and then times 1.05. And then if you weren't sure exactly what it would work out to, you could just put in here, for example, 36 divided by 12 for M divided by 12. Okay, 1157.625, so that's correct. And then I'm just going to save time and not do the last one since we've already found the correct answer, but it's going to be a gigantic number because the exponent is 36 times 12, and you raise 1.05 to that, you know, large exponent and so on. So that's an alternate method you could use to solve this problem, again, using the strategy of picking numbers. Now, right below it, we have problem number 25. And this one basically is a form of a quadratic equation. So notice if you just let x minus x minus 5 equal just say y, or you could pick whatever variable you wanted. So in other words, make this a y and make that a y. So now you have y squared plus 10y plus 25. So even though the original equation might look like something you're not familiar with or not able to solve, if you just do the simple substitution, now it looks like a basic quadratic equation, and this you could solve by factoring. That's probably the quickest method. You could also solve this by using your graphing calculator as well, using the zero function. So I'm just going to factor it. It's going to be y plus 5 times y plus 5, and then you just set each factor equal to 0. Well, they're both the same. It's a repeated root. And so you get y equals minus 5. So notice, technically that means that x, if you go ahead and solve it out, now going back to the original equation, if you plug, you know, the value of y back in here and then solve for x, so x is actually equal to 0. But now it's basically telling us how many distinct real solutions does it have? Well, just one. The answer is going to be B. Exactly 1. There's only one answer, and it is x equals 0, and that's it. You could technically have known that when you got to this step right here, because if there's only one value for y, then that means there's only going to be one value for x. But I just went through the extra work just to kind of show you and confirm that there's only one real solution to this equation. Below that, we have problem number 26. Here you are given one equation in a system of linear equations. It tells you that the system has exactly one solution, and then it asks for which one could be the other equation in the system. So there are multiple ways that you could approach this. Basically, so one method, or what I think is the easiest method, is when you have a system of linear equations and they are written in standard form, meaning the x and y's are both on the same side and the number term is on the other side, for there to be exactly one solution, the multipliers on the x and y terms from like equation 1 to equation 2 have to be different. So if I took answer choice A, all right, and I checked that, notice the multiplier here. In other words, how do I get from 4 to negative 4? The multiplier is negative 1. And then do the same thing for y. The multiplier from negative y to positive y is again multiplied by negative 1. So for this answer choice, the x and y have the same multiplier. That means that this will not be a one solution case. Technically, this one's going to be no solution because the multiplier over here is positive 2, and the number multiplier is different than the x's and y's. But in any case, it's not one solution, so we cross it out. So now let's go ahead and check just some of the other answer choices here. So 4x minus y equals 3. Notice here, again, it's times 1, and here, again, it's times 1. So that means this is not one solution. Again, we're looking for the x and y to have different multipliers. So now we'll check answer choice C. 4x plus y, okay, equals 5. Here, the multiplier is positive 1. So times 1. Here the multiplier is times negative 1. So now these two multipliers are different. Therefore, this will be our correct answer. So that is one method that you could use to figure out the answer and to solve it. Here is another method, and this might take you a little bit longer to do on the calculator, but it's just another way that you could do it. So you can solve systems of linear equations on the calculator using matrix operations. And so what I'm going to do is I'm going to attempt to solve these, but whenever you use these matrix operations, if it's a no solution or if it's an infinite solution, the calculator will give you an error. When it's a one solution, when there's exactly one solution, the calculator will actually solve it out. So here is what I mean. So let me erase the possible answer choices and show you how we do that. So I hit alpha and I hit zoom to get into the matrix menu. And the first thing I'm going to do is I'm going to bring up a blank 2x2 matrix. And here I'm going to put in the coefficients of the x and y terms. So for the first equation, it's going to have 4, negative 1 on top. And then on the bottom, it's going to have the coefficients of my answer choices. So for example, negative 4 and positive 1 is what I'm going to check first. Negative 4, positive 1. Then I'm going to put a negative 1 exponent. Don't worry about why you do that. Just that's basically something to know or to memorize that you do. Then I'm going to put in a matrix which has 2 rows but only 1 column, and that's where I'm going to put the 2 numbers in. And so, for example, at the top of this, I'm going to have 3 first and then 6 at the bottom. Okay, so now if I hit enter, notice it gives me an error. The fact that it gives me an error tells me that it's either no solution or infinite solutions. Therefore, I know that this is not the answer to the problem because the answer to the problem is going to have exactly one solution. So whatever, I'll quit out of here. Now let's say I checked answer choice C. So the top row is not going to change. That's still going to be 4, negative 1, 3. But the bottom row is going to change. So for answer choice C, I've got a positive 4 first, so I'll delete that negative. Then I've got a positive 1, so I guess that actually will not change. And then over here, although it doesn't affect the answer, I'll make this 6 into a 5. And now I hit enter. Notice it returns a value. That's what tells me that the system of equations has exactly one solution. Also, just real quick on this problem, one other method that you could use to solve it is you could compare the slopes of each of these lines. You're looking for different slopes when you have a system of equations with one solution. That's how the two lines will intersect. They just have different slopes. So in this top one, if I just rearrange this and I just basically added y and then subtracted 3, I would get 4x minus 3 equals y. So the slope of this first line is 4. And now you could just go through and basically calculate the slopes of the rest of these lines, and you would see which one has a slope which is not positive 4. So in the last one, the slope is going to be the same. It's going to be positive 4, so that's not it. Same thing in B. If you add y to the other side and subtract 3, you're going to get, again, a slope of positive 4. In A, if you add 4x to the other side, you're going to get, y equals 4x plus 6. So you get a slope of positive 4. So that would eliminate that one. And then C is where you get a slope of negative 4. Y equals negative 4x plus 5. Therefore, it's a different slope. Therefore, it has exactly one solution. So those are 3 different methods you could use to solve this problem. Below it, the bottom of the page, we have number 27. Here we have a problem where you're basically setting up just a basic ratio, basic kind of like proportion. So we know that essentially 4 inches, actual length 9 feet. And then they tell us the actual length of the object here is 12y feet. So we'll just use this expression, whatever, 12y, and then which represents the length in inches. So like, say this is just x up here. We're solving for this variable. You just set up a basic proportion, inches on the drawing on top, actual length bottom. Inches drawing on top, actual length bottom. Then you just rearrange this to solve for x. So if you just cross multiply both sides, you get 9x equals 48y, and you just keep that variable in there. Then just divide by 9. So you get 48y over 9. And then this you can just simplify, either by hand, just dividing each thing by 3. And it's going to be 16 over 3. So the correct answer is going to be letter C. Or you could just do it on the calculator. You could just enter it in as a fraction, 48 over 9, hit enter, give you 16/3 as an answer. So correct answer, letter C, 16y over 3. By the way, you could also do picking numbers with this strategy. The way it would work is you would pick a number for y, and then once you work it out, you find what the actual length is in inches. So here, I'll just show that method as well. I'm going to let y equal 3. Okay? So in other words, 4 inches, actual length 9 feet. So I let y equal 3. That means actual length is 36 feet, and total number of inches we don't know. So now this proportion, I'm actually not going to cross multiply it. I'm just going to notice that like the bottom is times 4, so the top is going to be times 4. So that means the inches is just going to be 16. So now, if you go through the answer choices and you plug in 3 for y, one of these will equal 16 and the other 3 will not. So here, if I multiply by 3, these cancel out and I get 4, not 16. Letter B, 3 times 3, not 16. Here, plug this in, the 3's cancel out, and I get just 16. That matches, correct answer. And the last one, 27 times 3, 81, not 16. That's just an alternate method where you could use picking numbers to find it if you're just uncomfortable or not sure what to do about the 12y term. Okay, now at the bottom of this page we have problem number 28 where we have a couple scatter plots. Or I guess actually, sorry, no, these are dot plots, not scatter plots. But ask some questions about the means and the standard deviation. So for the mean, I mean, you could technically punch these into your calculator and figure them out. Meaning for A, you could do like 2 times 10 plus, what is it? 1, 2, 3, 5 times 15 plus 6 times 20 plus 5 times 25 plus 2 times 30. And you could add them all up and divide, by the total number. But you don't need to actually do that. The means for these are each going to be equal because there's basically like the same number of dots, like, spaced out kind of the same distance from each like center thing. In other words, 20 is here in the center in both of them, and for the average, you have some up here and you have some up here. And you got the same number down here and same number down here. So you don't actually need to calculate this, but you can. But the mean or the average is going to be equal in both of these, just because they're basically distributed symmetrically about the number in the middle, which is 20. However, the standard deviations are not going to be equal. The reason the standard deviation is not going to be equal is because the standard deviation describes like how spread out a set of data is, meaning how far away from the middle or from the mean are the different values. So notice in dataset A, you only have 2 values that are 10 units from the mean, and you only have 2 values that are 10 units above the mean. So you have 2 below and 2 above. And every other value is within 5 units. Like, notice how they're clustered here, much closer to it. Whereas in dataset B, you have 4 values that are 10 units away, and 4 values that are 10 units below and 10 units above. So in dataset B, the values are spread apart much further. They are not clustered as close to the center or the middle. Therefore, the standard deviation for A is going to be smaller than the standard deviation of B. So just based on that fact alone, it's going to be, basically answer choice A. So even if you weren't sure exactly about calculating the means or finding the means, just the description of the standard deviation between the two will lead you to A being the correct answer for this problem. Okay, and again, just to kind of briefly summarize, the data in set B is more spread out. The values are farther apart from the mean or from the middle, as compared to set A, where most of the values, like all of them except for 4, are within 5 units, of the center or of the mean. That's why the standard deviation of A is smaller than the standard deviation of B. And answer choice A is the only one that has that fact in it. And the standard deviations are not going to be equal, obviously, because, the data values themselves are not equal. There are some closer in A and some further apart from the mean in B. At the top of the next page, we have problem number 29. And so for this problem, the easiest way to do it, I believe, is just to use the strategy of picking numbers. So if you're not sure about the theory of it, let's just let x equal 100. Okay? So we have the starting number of 100, and we're going to decrease it by some percentage, and our answer is going to be 0.7x. So if we start off with the first one, we start at 100, we decrease it by 70%, which means we're really taking away 70 from it. So our final answer is just 30. If we looked at answer choice B, again, we're starting at 100, we're taking away 30%, so we're taking away 30, and we would end up at 70. Answer choice C, we would start with 100. Again, we would take away 7%, and so we take away basically just 7, and that would leave us at 93. And now answer choice D, we'd start at 100, we're taking away 3% of that, which is just 3, and we'd end up at 97. Now, which one of these is equal to 0.7x, where, again, x equals 100. So 0.7 times 100, and that you could just do it on the calculator if you weren't sure, but that just equals 70. So which of these answer choices leaves us with 70? So obviously it's letter B, 30%. So the correct answer for this one is going to be letter B. And just to talk about now the theory behind this a little bit. So when you have these problems where it's like, whatever, like 0.7x or 0.6x or point whatever x, basically, and you're talking about decreasing something. Basically what happens is, like, the remaining amount that you have, in other words, here it's the 0.7x, like that is going to be equal to a decrease in the original quantity by whatever decimal you add in order to equal 1. So in other words, it's like if you started with 1 and you subtracted the 0.7 from it, what you are left with is zero point 0.3, because zero point 0.7 plus zero point 0.3 is what equals 1. So in other words, if you end up with like 0.7x, it's like whatever you have to add to that to equal 1, which in this case is zero point 0.3, that is the equivalent decrease that you do to the original quantity. So the two numbers, the point is the end result and the amount you decrease by together basically add up to 1. All right, the next problem on the test is number 30, and this is a very tricky question because they tell you that this graph that they show you is not the actual function f of x that are the answer choices, but it's f of x plus 1. So the actual function that you're trying to figure out is not going to cross the y-axis at 2. Instead, it's going to cross it at 1. And it's not going to intersect it at 1 comma 4. Instead, it's going to be down here at 1 comma 3. And the reason is because notice there's this plus 1 here, right? So that means we take some unknown function and we shift it up by 1 unit. And that's what you have the picture of. This picture right here is f of x shifted up by 1 unit. So for the actual f of x now, basically we would just shift each point down by 1 unit. So f of x itself is going to look something like this. Now there are multiple ways that you could do this problem. I think the easiest way that I would do is I basically took some of these points and I just plugged them into the answers. So 0, comma 1 and 1, comma 3. So if you just go down through initially and you plug in 0 for x, and okay, you get 2 to the 0, which is just 1. So for the first point, this one works. Then here for the next one, 3 to the 0 is 1, so that one checks. Here we have 2 to the 0, which is 1, so we get 1 plus 1, which is 2. That does not match the y value we expect, so cross it out. And this is going to be the same. It's 3 to the 0 is 1, and 1 plus 2 is 3. So right away, we've gotten rid of C, we've gotten rid of D. Now we just have to check these two and see which one of them has the point 1, comma 3 on it. So obviously 2 to the first, or 2 to the x, is 2, and 3 to the first is 3. Well, which one, matches? It's obviously going to be letter B right here, 3 to the x. So the correct answer is letter B. Now, of course, an alternate method you could use is you could graph these equations out on the calculator, and then you could figure it out just from that. So just to show you an example, let's say I wanted to graph out, I'm not going to graph out all 4 of them just to save time, but let's say I'm going to graph out answer choices A and B. So first I'm going to do 2 to the x. Now, you do have to use basically the points that are on the graph to confirm whether the graph on your screen is correct or not. In other words, you're not really going to be able to just look at it and tell, if this is correct or not. So then I would just go to basically the table of values, and I would say, okay, does it have 0, 1? Yes, it does. Okay, does it have 1, 3? Nope, it has 1, 2. All right, that's not it. Eliminate that out, and then I would go to 3 of x, and then you could, this one's graphed out. And then again, the same thing, I would go to the table, and I would go down to 0, and I would say, okay, does it have 0, 1 on it? Yep. Does it have 1, 3 on it? Yep. Okay, that's the right answer, and so on. And you could check C and D, but those won't have both the points. So that's an alternate way where you could use the calculator instead of actually plugging the points in, but you do need to get the actual points from the graph first. Okay, the next problem that we're going to take a look at is problem number 31, just below it. So this problem basically is really just a dimensional analysis, like kind of unit conversion type problem. You're just starting with something, you're just starting with a distance of 4 centimeters, and they want to know what it's equal to in meters. So we just have 4 centimeters, and we know that 100 centimeters is equivalent to 1 meter. And then you just go ahead, you can multiply this out on the calculator. The centimeter units cancel out. Basically, you get 4 over 100. That just reduces to 1 over 25. Or, if you already know, 4 divided by 100 is just 0.04. So for our first gridding question, it's just 0.04, and that's it. Nothing else to do. Fairly basic problem. Next grading question, we have number 32. For this one, the easiest way is just to go ahead to solve out this equation. So we've got, 7x minus 21 equals 2x minus 6, and then subtract 2x on both sides and add 21 to both sides. So we get 5x equals 15. Divide by 5 on both sides, x equals 3. And now be careful, they do not want the value of x, they want the value of x minus 3. So 3 minus 3 equals 0. Therefore, correct answer to this problem is 0. You just grid in 0 and nothing else. Okay, moving on now, problem number 33. So for this problem, you are given a it's technically not a quadratic expression, but after you factor out a common factor, it actually can turn into that. So they tell you that a factor of this expression is x plus b. What is one possible value of b? Okay, so there are actually two possible answers for this. Essentially, what you're doing is you are factoring this expression. That's it. So the first thing I would notice is that each of these terms can be divided by 2, in other words, has a common factor of 2, and has a common factor of x. So factor that out, you get x squared plus 7x plus 12. Now, you can go ahead and just factor by setting up 2 parentheses here. So I'm looking for factors of 12 that add up to 7. So 1 and 12, nope. 2 and 6, nope, they add up to 8. 4 and 3. Okay, so positive 4 and positive 3 are going to be my two factors. So now, the answers to this question are going to be either 4 or 3. Okay, so there's two possible correct answers you could put. Obviously, you only put one of them, so either just grid in 4 or just grid in 3. But the b values in this thing, where it says x plus b, where b is a positive constant, it's just this number, and that's it. Now, jumping to the top of the next page. Next problem, we have number 34. Here we have a frequency table, and there are 109 total entries in this frequency table, and we know that because they tell us it, right here in the problem. And they ask us for, basically they're just asking for the median. So all we have to do is just realize that we take 109 and we divide it by 2. We get 54.5. We then round that up to 55. So what that tells us is the 55th value, going from either smallest to largest or largest to smallest. You can technically go either direction, but the 55th value is going to be the median value. So all we have to do now is go down the frequency column, and we're just going to keep adding until we get to 55. And then whatever number is in the class size column, that's our answer. So 10 plus 13 is 23. 23 plus 30 is 53. So going through these first 3 rows, we've hit 53 total values. And we need to hit 55. So now we go down here. At the end down here, 53 and 36 would be 89. So that means the 55th value is basically in this row, and therefore it's just going to be 24. So the median class size at this high school is just 24 students. Correct answer, you just grid in 24. Next up, problem number 35. For this problem, it's technically a system of equations that you're going to set up, but fortunately we can solve it on the calculator. So basically the way that this problem is going to set up is you have the amount of hours that he spends walking and biking adding up to 2. And I'm actually going to come back to this equation just in a second. So I'm going to let x be whatever, the walking, and y be the bicycling. So we spent a total of 2 hours walking and bicycling in a week. Okay. Then the second equation is going to deal with total number of calories. So it's going to equal 531 because that's how many calories he burned. And we also know that he burns 4.2 calories per minute walking. So that's going to be multiplied by x. And then 5.1 calories per minute bicycling. Except here's the problem. The question says how many minutes did he spend walking? So when I first set this up, I let my x and y be number of hours. That's why it's equal to 2. But what I'm actually going to do now is I'm going to change this first equation, and I'm going to let x and y be the number of minutes that he is walking and bicycling. So that means on the right side, it's not going to be 2, it's going to be 120 minutes, because 2 hours is just equal to 120 minutes. You just multiply by 60. So my first equation is x plus y equals 120. That is the total number of minutes he spent doing each activity. And then the second one is total number of calories burned. Now, you could solve this out by hand. I'm not going to bother doing it just because of the decimals and the amount of work involved. I'm instead just going to go straight to the calculator and solve it using basically using matrices on the calculator. You could also, I guess, technically graph it if you wanted to, but the problem is the number comes out so large that you're going to have to keep zooming out to actually find the intersection point. So, first thing we need to do is go to the matrix menu by hitting alpha zoom, and I need a 2-row, 2-column matrix. Okay, and so basically what I'm going to enter in is the coefficients of the variables in that, and then I'm going to raise it to the negative first power. And then on the right, I'm going to do another matrix, and that is going to have just the 2 numbers. So for here, I'm going to have 1, and then 4.2, and then 5.1, and then up here just a 1. And now again, after you do that, you make sure to actually to solve this out the way that these matrix properties I'm using on the graphing calculator, I raise this to the negative first power. Don't worry about why you do that. Just basically just got to memorize that's how you do it. Now I need another matrix, so I do alpha zoom again, and now, like I said, it's going to be a 2-row but 1-column matrix. So once I have that, I click OK. Now I'm just going to put 120 on the top and 531 on the bottom. So now I've got all the coefficients entered in. I'm just going to hit enter, and it's going to give me the answer. Okay, so notice the answer comes back as 9030. Okay, it looks basically, something like this. So the top number is always for the first variable, so this is for x. The bottom number is for the second one. So x is what I used for walking because that is, first of all, what I wrote, but also that's what corresponds to the 4.2. So that means the correct answer to this problem is just 90. So you just grid in 90, and that is the final correct answer. 90 minutes were spent walking. Now, the problem below that, number 36, deals with some geometry, and specifically, this is a I don't know, like a theorem or property in geometry that you very rarely see on the SAT involving chords that intersect in a circle. So basically, what's going on here is we know ux, tells us that ux bisects yw at point C. So that means this and this are each the same length. And notice it also tells us later that wz is root x. So that means this is root x, and also this segment is root x as well. It also tells us the radius of the circle is 6. So that means from O to U is 6. And from x to z is 2. So this little line segment up here is 2. Now, OZ is just going to equal 4 because from O to x is 6, and from z to x, or x to z, however you want to write it, is just 2. So if you subtract those, that will give you the distance from O to z. So that's just going again to equal 4. So this little part here is 4. That means that this entire thing from U to Z will be 10. Now, here's the theorem that from geometry that you use to actually solve this. When two chords intersect in a circle, you multiply the segments of each chord together and set them equal to each other. So just because this picture is kind of cluttered, just to kind of show you what I mean. So let's say I had this right here. So I would multiply these two red segments together, whatever their values are, and I would set them equal to the two blue segments, whatever they are, values multiplied together. So for this problem, that means I have root x, which is this segment right here, times it's going to multiply by root x again because it's multiplied by the other part of wy. So it's root x times root x. And then we set that equal to this line segment, which is 10. And then times this small line segment, which is 2. So in other words, square root of x times square root of x is just x. It's technically square root of x squared, but the square root and the square root cancel out. And 10 times 2 is just 20. So the correct answer for this problem is just 20. That's it. No more work is needed. You do have to know that theorem from geometry that when you have two chords, by the way, chords are line segments that start and end on a circle. When you have two chords that intersect in a circle, you multiply their segments together on each chord and then set them equal to each other. All right, the last two questions coming up, 37 and 38, both deal with this graph here. So for the first one, problem number 37 is actually a very simple question. just wants to know like what's the predicted velocity at the depth of 4 feet. So we just go to where the depth is 4 feet right here on the x-axis, and we go up and here, and we look at the best fit line, and we say, okay, what's the velocity here? Well, we go over, it's 1.2. So that's it, 1.2 feet per second, and just grid that in, nothing else to do. Fairly, basic, fairly simple problem, just reading a graph. Now, for problem number 38, it asks basically it's basically asking for a probability, but it says for what fraction. For what points is, okay, the velocity predicted greater than measured. So in other words, it's really asking for, predicted greater than actual. What this means is you want for this situation, for the predicted line of best fit giving a greater or higher value than the actual measured velocity, it means that you want the points that are under the line. Because the predicted value is on the line. The actual value or the measured value are the actual dots, on the graph. So for this question, for predicted by the line of best fit to be greater than the actual, you want this one right here and this one right here, that's 2. You want this one right here, 3. You want this one right here, 4, and this one right here, 5. And then, so there are going to be 5 points that meet their criteria, and how many total are there? Well, you could count them up and notice that it's 11, or it gives you that information right in the problem. Right here, 11 measurements of the velocity. So the answer to this question is going to be 5 over 11. So you could grid it in that way. However, if you wanted to grid it in as a decimal, you could also do 0.454 or 0.455. In other words, you could truncate it, which is the first example, or first number, or you could round it where it would go to 0.455. So either of these three would be acceptable. And just one last thing, a lot of students on questions like this basically get this backwards and see, the predicted line of fit greater than the measured, and they look for the points that are above the line. But again, it's actually the opposite. If the predicted is greater than the actual, that means that you want the points below the line. If they want predicted less than the actual, that means you would want these points here, above the line on the graph. All right, so this is the calculator section of the May 2022 SAT QAS, basically section 4 of the test. If you like this video, please make sure to give it a thumbs up, and of course subscribe to my channel and sign up for notifications. I will actually have a lot more SAT math related content coming up in the next couple of weeks. I've mainly had ACT math content so far, but don't worry, there will be plenty of SAT math related content coming up as well.